All right, let's dive into this. Brain transplants and cryonics. I mean, wow, this stuff is straight out of, like, a sci-fi movie, you know?
Yeah, it's pretty wild stuff, you know.
But we're going to try to, like, separate the fact from the fiction today. We've got some great source material to work with, so we're going to really try to unpack all this.
Definitely.
Let's start with cryonics, since that's probably the closest to reality at this point. You know, we've all heard those stories about people being frozen, hoping to be revived in the future, but what's the actual science behind that?
Well, so cryonics is basically the process of preserving a person's body at extremely low temperatures.
Okay.
After they have been legally declared dead, of course.
Right.
Usually, this is done with liquid nitrogen. And the idea is that sometime in the future, technology will have advanced enough to revive them and, you know, maybe even reverse what caused their death.
So it's like hitting the pause button on life, hoping to hit play again sometime down the road.
Yeah, exactly.
Okay, but how does that even work?
Well, the process starts right after a person is declared legally dead.
Uh-huh.
The body is cooled down really quickly. And this is to try to prevent ice crystals from forming, which can damage cells. Then it's cooled even further to cryogenic temperatures, and it's stored in the special facility.
Wow, so, like, are there a lot of these facilities around?
There are a handful of them around the world, yeah.
Interesting. Okay, so we've got the body on ice, literally.
Right.
But is this actually, like, working? Can people really be brought back from this?
That is the million-dollar question. And honestly, we just don't know yet.
Okay.
Revival technology, it just doesn't exist. Not yet, anyway.
Right.
And, you know, it's a huge leap of faith to think that future science will be able to repair the damage from the freezing process. But not only that, but also, like, reverse the underlying cause of death. You know, it's a lot.
So it's like, it's a gamble on the future of medicine.
It is, definitely.
Okay, but let's play that out. Let's say revival does become possible. I mean, what are some of the challenges we'd face in actually bringing someone back? Like, what are the things we need to think about?
Well, one of the biggest challenges is going to be making sure that the brain remains intact.
Right.
And functional, right.
Yeah.
I mean, if you think about it, even, like, the smallest bit of damage to brain cells can have a huge impact on memories.
Yeah.
Personality, even just basic bodily functions.
Oh, yeah, for sure.
You know, it's extremely delicate.
So, I mean, even if we could bring somebody back, there's no guarantee that they'd be the same person. Like, even if their memories are there, is it really them?
That's exactly it.
Yeah.
And, you know, that brings up a whole bunch of ethical questions that we'll have to deal with at some point.
Yeah, for sure.
But for right now, the focus is really on perfecting the preservation process itself.
Okay, makes sense. So cryonics is all about preserving the whole body. But what about brain transplants? You know, our listeners are super curious about the idea of, like, transferring a brain to a machine.
Yeah, well, that's where things get even more speculative, you know?
Yeah.
I mean, we're talking about not just preserving the brain, but, like, integrating it with a completely artificial system. It brings up a whole new level of scientific and technical challenges.
So, I mean, even beyond just keeping the brain alive outside the body, like, what kind of challenges?
Well, we'd have to create something called an artificial substrate.
Right.
And that's essentially like a life support system for the brain.
Okay.
It would have to basically replicate all the functions of the human body. So we're talking about a constant supply of oxygen and nutrients, regulating temperature, managing all those hormonal signals, I mean, all that stuff.
So it's not just like plug and play, right? It's not just plugging a brain into a computer.
No, it's way more complicated than that.
It's like we'd have to create an entirely artificial body that can actually keep a brain alive and functioning.
Pretty much, yeah.
Wow. And then how would the brain even interact with this artificial body? I mean, how would that even work?
Well, that's where the idea of brain-computer interfaces, or BCIs, come in.
Okay, so I've heard of BCIs, you know, like those things that help people with disabilities control prosthetic limbs with their thoughts.
Right.
Is that the kind of technology we're talking about here?
It's similar, but on a much more complex level.
Okay.
I mean, current BCIs, they work by detecting and interpreting, you know, relatively simple brain signals. But for a brain transplant, you would need a BCI that can handle, like, a massive amount of information flowing between the brain and the body. So the brain could control movement, receive sensory input, and basically, you know, experience the world through this artificial substrate.
It's like, whoa, That's a lot. So it seems like we're pretty far off from that level of technology, right? I mean, what are some of the biggest hurdles?
Oh, there are a lot of hurdles.
Yeah.
I mean, first of all, the brain is incredibly complex. Billions of neurons, intricate patterns. We're still just like barely scratching the surface of how it all works.
It's like we're trying to read a book, but we don't even understand the language.
It's a good analogy. And then there's the whole issue of biocompatibility. I mean, you need to create electrodes and sensors that can interface with, brain tissue without causing damage.
Right.
Or triggering an immune response.
So it's a very delicate balance. Okay, so let's say, hypothetically, we do manage to figure all of this out.
Okay.
We've got the preserved brain, an artificial body to support it, and this BCI connecting them.
Right.
How do you actually do a brain transplant? Like, what does that procedure even look like?
Well, that would likely involve a really complicated surgery, probably using robotic assistance to minimize damage to the brain.
Oh, okay. So we've carefully removed the brain. Now what? Do we just plug it into the new body?
Well, not quite. Before we can even connect it to the BCI, we need to map the brain's neural connections. I mean, in incredible detail. Like, think of it as creating a personalized roadmap of that individual's brain. And this is absolutely crucial for preserving their memories, personality, and hopefully their consciousness, right?
So it's like we're making a backup copy of someone's mind. That sounds incredibly complex. I mean, how long would that even take?
It would be incredibly time-consuming.
Yeah.
And even then, there's no guarantee that transferring the brain would actually preserve the person's consciousness as we know it.
I mean, that's a big if, right? But, let's say we can successfully do it. We can transfer a brain and we can preserve consciousness. What then? I mean, what are the implications of that? What could we use this technology for?
Well, that's where things get really interesting. And we start to see the potential of this technology to, reshape our understanding of life and death.
Yeah.
But maybe that's a conversation for the next part of our deep dive.
You're right. We have covered a lot. We'll take a quick break, and when we come back, we'll delve into those potential applications. We'll explore what it could mean for the future if human consciousness could exist beyond our biological bodies. Stay with us.
Okay.
All right, so we're back. And before the break, we were getting into some really heady stuff. Like, what happens if we can actually transplant a brain into a machine? Assuming we can overcome those technical challenges, what are the implications of a brain living in a, non-biological body?
Well, that's where things start to get, less about the nuts and bolts and more about the philosophical, even the existential, really.
Yeah. I mean, it's a big jump.
Oh, it is.
Oh.
If consciousness can be transferred, I mean, what does that even mean for how we understand life and death,
Right. Like, are we redefining what it means to even be human?
I think that's exactly what we'd be doing.
Yeah.
Right now, our identity is so tied to our physical bodies, right? But if your brain, and therefore your consciousness, could exist in a machine, I mean, would you still be you?
Yeah, that's a big one.
Where does the self even reside?
Right. Like, are we just our memories and experiences, or is there something more to it?
Some people think that our consciousness is tied to the physical structure of the brain, like the specific arrangement of neurons,
Okay.
the synapses. If that's the case, then even a perfect copy of your brain might not really be you. It would be like a twin, I guess.
Interesting.
Same memories, but a separate individual consciousness.
So, like, if you were to upload your mind to the cloud or something, it would be like creating a backup, but the original you is still here.
Right, exactly. But there are other people who think that consciousness is more like software,
Okay.
like a pattern of information that could theoretically be run on different hardware. So in that case, transferring it to a machine is more like an upgrade.
Okay.
You're still you, you're just functioning in a different way.
So, I mean, that raises some really wild possibilities. Like, if consciousness is software, could we have multiple copies of the same person running around?
That's a really crazy thought, right? And it completely changes our understanding of individuality. Like,
Okay.
if there are multiple yous out there, which one is the real one? Does that idea of a single self even make sense?
It's mind-blowing. Okay, but let's say we step back from the philosophy for a minute.
Sure.
Let's talk practicality. If we can transfer a brain, how would a person actually adapt to living in a machine body? I mean, what would that be like?
Well, that is a huge question, and we'd need to rethink, psychology and rehabilitation completely. I mean, imagine waking up one day and your senses are completely different.
Yeah.
Your physical capabilities are changed, maybe even enhanced. Your whole worldview would be turned upside down.
Yeah, it'd be like being born into a completely different reality.
Exactly. So we'd have to figure out how to help people adjust, not just physically, but emotionally and mentally.
And then, I mean, there are the societal implications too, right? Like, how would the world react to people living in these machine bodies? Would they have the same rights as everybody else? Would they even be seen as human?
Those are big questions. I mean, really crucial questions.
Yeah.
And honestly, we just don't know. We're talking about a complete shift in how we define what it means to be human. Society would have to adapt along with the technology.
Yeah, that's a lot to consider. And we're still just talking about transplanting an existing brain. What about machines becoming conscious on their own? You know, machine sentience, like our listener was asking about.
Right. Well, that adds a whole other layer of complexity, doesn't it?
Yeah.
I mean, the idea of the singularity, the point where artificial intelligence surpasses human intelligence, has been debated for, decades now.
Right.
Some experts think it's going to happen for sure. Others think it's impossible.
Yeah, I mean, I have to admit, the idea of sentient machines is kind of freaky, you know? Like, what if they decide they don't need us anymore?
Yeah, that's a classic sci-fi fear, isn't it?
Yeah, it is.
But even if machines don't become conscious the way we understand it, they're becoming incredibly sophisticated.
So maybe we don't have to worry about robot overlords taking over. But we still need to think about what it means for AI to get more powerful and be more integrated into our lives.
Oh, absolutely.
Yeah.
We need to make sure it's developed ethically,
Mm-hmm.
with safeguards to make sure nothing goes wrong. It's not just about the tech itself, it's about how we use it.
Right, how we integrate it into society. It seems like every step forward just creates more questions.
It definitely does.
I mean, this is a lot to wrap your head around.
It is. But in all this uncertainty, there's also a sense of incredible possibility.
Yeah.
These advances could completely change what it means to be human and how we interact with the world.
So, I mean, how do we navigate all of this? Where do we go from here?
I think it starts with conversations like this one,
Yeah.
Open, honest conversations. We need to bring everyone to the table. Scientists, ethicists, policymakers, the public. We need to talk about the potential benefits and risks of these technologies.
So it's not just about what we can do, it's about what we should do.
Exactly. What kind of future we want to create.
And speaking of the future, maybe it's time to bring cryonics back into the conversation. It might seem like a separate thing, but it's really all connected to these bigger questions about extending life, right?
Absolutely. Cryonics is about preserving the possibility of a future for individuals and maybe even for humanity as a whole.
Okay, so let's shift gears and go back to cryopreservation. Explore the latest stuff that's happening, the challenges, the ethical dilemmas about our relationship with death.
Okay, sounds good.
So for everyone listening, stay tuned as we delve into a future where death might not be the end, but maybe just a pause. Welcome back for the final part of our deep dive. I feel like my brain is about to explode. We've covered so much, but it's been so fascinating.
It really has. Brain transplants, machine consciousness, now back to cryonics. It's all connected in a way, isn't it?
Yeah, totally. Cryonics is all about preserving the possibility of a future for individuals, maybe even for humanity as a whole. Before the break, you mentioned some pretty exciting advances in cryonics. Can you tell us more about those?
Yeah, definitely. I mean, we're still a long way from being able to revive a cryopreserved person, but the research is, moving forward.
Oh, okay.
Scientists have gotten a lot better at preserving organs, for example.
Oh, wow.
And there are even some companies that are offering cryonic services for pets now.
Really? For pets? Wow. So this isn't just some fringe science fiction idea anymore.
Not at all. I mean, it's still early days, but there's real science happening here.
Okay, but what about the challenges? I mean, I imagine there are still a ton of those.
Oh, absolutely. I mean, one of the biggest is preventing damage to cells and tissues during the freezing and thawing process.
Mm-hmm.
Think about trying to freeze something as complex as the brain.
Right.
Without causing any ice crystals to form. I mean, that could completely destroy the cells.
That sounds insanely difficult. Are there any solutions in sight?
Well, researchers are trying all kinds of things. Different cryoprotectants, new cooling techniques. They're even looking into nanotechnology, which could maybe be used to repair damage at a really tiny level.
Nanotechnology, huh? It seems like every field is getting into nanotech these days.
Yeah, and has a lot of potential applications, that's for sure.
Okay, but let's say we get to the point where we can perfectly preserve a person. Reviving them, I mean, that's a whole other problem, right?
Oh yeah, that's the real hurdle. You'd need some incredibly advanced technology to be able to repair and restart all the systems of the human body.
And I mean, assuming we even understand what it means to be alive in the first place.
Right, exactly. Consciousness, memory, personality, all that. I mean, We're still just figuring all that out.
So cryonics is about the future of technology, but also about these big questions about life and death, you know? What do you think drives people to choose cryonics? I mean, knowing that it's such a long shot.
That's a good question. I think for a lot of people, it's that deep human desire for a second chance. A chance to experience more life, even if it's in a future they can't even imagine. It's a huge leap of faith.
Yeah.
But it's also a bet on the power of science to go beyond what we think is possible.
I mean, the implications are just mind-blowing for individuals, for society. Like, imagine if we could live much longer or even achieve some kind of immortality. How would that change us?
It's hard to even grasp, right?
Yeah.
But it's important that we think about these things. We need to approach these advances with, a lot of care, thinking about not just the science, but also the ethics and the potential consequences.
Totally. It can't just be about what we can do. It has to be about what we should do.
Yeah.
This whole deep dive, it's really been a trip into the unknown. I mean, exploring the frontiers of science and these huge questions about consciousness and identity and the future.
It really has. And I think the biggest takeaway is that we're living in a time of incredible scientific progress. These advances are pushing the boundaries of what we thought was possible and making us confront some really profound questions about what it means to be human.
So as we wrap up, what's the one thing you want our listeners to remember?
I hope they come away with a sense of wonder and curiosity about the future. These technologies may seem like science fiction, but they're pushing the limits of what we thought possible. It's up to all of us to be part of these conversations, to ask the hard questions, and to make sure that these advancements lead to a better future for everyone.